All right, so this is the review assignment for the retake for the second test in Chapter 4 over sections 5 and 6. So the first question on the review asks us to use the rule of signs to determine how many positive and negative x-intercepts, or zeros, that the function can have. Okay, so we're thinking of the rule of signs, and I'm going to look from one sign to the next. So this first term is positive, so I go from positive to negative, so there's one sign change. Negative to negative does not change, but negative to positive does change. So there's two changes, which means for f of positive x, we're going to have either 2 or 0 positive roots. Now, if I look at plugging in f of negative x, if I plug in a negative with an odd exponent, I'm going to change the sign. Okay, so this is a negative with an odd exponent, so I'm going to start off with negative 3x to the third. An even exponent does not change the sign because when I square a negative, I get a positive, and that would just keep the sign the same. So that's minus 4x squared. Here's an odd exponent because it's to the first power. So I have negative 10 times negative x is plus 10x. Change the sign there. And then I have a plus 9. And from this, I'm looking at sign changes. So here I start with negative, go to negative, and now there's a negative to positive. So this is a sign change, and from positive to positive, it doesn't change. So that tells me when I plug in negative x, and I have one sign change, so one change, means I'm going to have exactly one negative root. Okay, I can't have 1 and 0 because I'm taking away pairs. Okay, so we look at pairs of roots if it's 0 or 2 up here. So there aren't any other odd numbers greater than 0. So I'm just stuck with one negative root. Number 2 asks us to list all of the positive or possible x-intercepts. This is where I'm looking at p and q's. So p over q, my p is the last factor, which is 30, and my q is the first one, which is 3. And I'm looking for all of the factors that go into 30 and 3. So for 30, I get 1, 2, 3, 5, 6, 5 times 6, 3 times 10, 2 times 15, and 1 times 30. Okay, so these are all of those roots, and then I'm going to put all of the factors of 3 on the denominator, which are 1 and 3. So I'm going to now pair up every top number with each of the bottom numbers. So keep in mind, I can have positive or negative values here, and all of the top numbers divided by 1 just give me the same number. So I have 1, 2, 3, 5, 6, 10, 15, and 30. Now I'm going to take each of these and divide by 3. So I have 1/3, 2/3, 3/3 is 1, and that's already there. So I have 5/3, 6/3 is 2, 10/3, 15/3 is 3, and 30/3 is 10. All right, so these are all of my possible rational roots. Number 3 asks us to simplify the powers of I. So this was not on our first test, but it was in our notes. So just to review this, I'm looking at powers of I. So if I have I to the first power, anything to the first power is just what you start with. So that's just an I. I squared is -1. I to the third power is an I times a -1, which is -I. And I to the fourth power is the same thing as I to the 0 power, which is 1. And these tell us our remainders. Okay, so this cycles through. And if I want to find the 5th power, I go back up to 1. The 6th power would be -1. The 7th power would be -I. And the 8th power is 1. And I keep cycling through. So what I really need to do is determine how or what my remainder is if I were to divide 4 into 7. I know 4 goes into 7 one times, subtract 4, and I get remainder 3. If I get remainder 3, I'm looking at I to the third power, which is -I. So I divide the exponent that's given by 4 and look for the remainder, and the remainder would be the exponent that is attached to I. So if I do 4 into 50, 4 goes into 50 12 times. 12 times 4 is 48. Subtract, I get remainder 2. Remainder 2 is I squared, and that's the same thing as -1. If I divide 76 by 4, 4 into 76, 76. 4 goes into 7 one time, remainder 3. 4 goes into 36 9 times. 19 times 4 is 76, remainder 0. So if I had I to the 0 power, following the rules for a number to the 0 power, anything to the 0 power is 1. Okay, and that's why I'm not going to get remainder 4, because if I do get a remainder 4, it's going to go in another time. So I would end up with remainder 0. If I divide 4 into 111, 4 goes into 11 2 times, remainder 3. And that would be 4 times 2 is 8, remainder 3. 4 goes into 31 7 times, remainder 7 times 4 is 28, so that would be remainder 3. And I to the third power is -I. Number 4 wants to know if x plus 4 is a factor. And I can do this a couple ways. I can look, and my 0 in this case would be -4. I could do long division with x plus 4 into this. I can plug in -4 in for each of my x values to see if I get a 0, or I can do long division, or I'm sorry, synthetic division. So I'm going to do -4, and then I'm going to look for all of my coefficients. So I have a 6th power, I'm missing a 5th, then a 4th, I'm missing a 3rd, a 2nd, I'm missing a 1st power, and then a 0 power. So I have 1x to the 6th, 0x to the 3rd, -16x to the 4th, 0x to the 3rd, 1x squared, 0x to the 1st, and -16. So I'll bring down the first number. -4 times 1 is -4. Add down, that's -4. Negative 4 times negative 4 is positive 16. Add down, I get 0. Negative 4 times 0 is 0. Add down, I get 0. Negative 4 times 0 is negative 4. I'm sorry, is 0. Add down, I get 1. Negative 4 times 1 is negative 4. Add down here, I get negative 4, and negative 4 times negative 4 is positive 16. Add down, I get remainder 0. So yes, x plus 4 is a factor. And I know that because we get remainder 0. Number 5, solve for x over the real and imaginary numbers. So just looking at this, I know that because my highest exponent is 4, I'm going to have 4 factors. If I look at sign changes, from positive to negative, there's 1, and now I have all negatives at the end. So I know that I'm going to have 1 positive factor. And if I look at plugging in f of negative x, negative to the 4th power stays a positive. A negative to the 3rd power will change this sign to a positive. A negative to the 1st power will change this sign to a positive, and my minus 16 sign will stay. And now I see I have 1 sign change. So I'm going to also have 1 negative root. Okay, so if I only have 1 positive root, 1 negative root, that means 2 of my roots will be imaginary. Okay, so that would give me my 4 roots that I'm going to need to solve this equation. So now if I look at all the possible P's and Q's, 16 has factors of 1, 2, 4, 8, and 16. And 1 is just a 1. So I can have positive and negative 1, 2, 4, 8, or 16 be my possible rational roots. Now, this is where I can use Desmos to help me find out what those roots are. And when I put my equation into Desmos, I look for the x-intercepts, and I'm going to have an x-intercept at -1, and I'm going to have an x-intercept at 4. So here's my positive and negative roots that I have here. So now I need to find my 2 imaginary roots. Now I do that by using synthetic division to kind of pare down my exponents. So in synthetic division, if I try -1 first, and I'm going to write the coefficients. I have a 4, 3, I'm missing an x squared, so I have to hold that with a 0, and then 1 and 0. So the coefficient of x to the 4th is 1, x to the 3rd is -3, x squared I don't have, x to the 1st is -12, and then I have -16. So I'll bring down my first number, that's 1. I'm going to multiply, that is -4 when I add down. -1 times -4 is 4. Add down, I'm going to get 4. -1 times 4 is -4. Add down, I'm going to get -16. And -1 times -16 is +16. Add down, I get 0. So this is what I get when I divide my polynomial by x plus 1, because that's the factor. Okay, the 0 is -1. Now I'm going to do the same thing with 4. Do I want to do it here? I'll just do it here. I didn't leave a whole lot of room here. But when I do synthetic division with 4, I'll bring down the 1. 4 times 1 is 4. Add them, I get 0. 4 times 0 is 0. Add, I get 4. 4 times 4 is 16. Add, I get 0. So there's my remainder. And the equation I have left, this would be my constant term, linear term, quadratic term. So this is going to be 1x squared plus 4. And that equals 0. So if I solve for x here, subtract 4, and x squared would be -4. Now I do the square root of both sides, and x equals plus and minus 2i. So x is plus and minus 2i, and those are my other roots. X equals 2i and x equals -2i. All right, number 6. I know I kind of wrote over the directions. Find the polynomial of degree 4 when x-intercepts are 2, 4, and -i. Well, remember, if I have a -i, I also have to have a positive I because they work in conjugate pairs. So my factors would be x minus 4, x minus 2, and then I have an x plus I, and then an x minus I. When I multiply the two binomial factors with real numbers, I'm doing FOIL here. So I have x squared minus 2x minus 4x is minus 6x, and 4 times 2, that's plus 8. So that's what I get when I multiply the first two factors. When I multiply x plus I and an x minus I, I'm going to have an x squared, and the coefficient of I is 1. So 1 squared is 1, and this is going to be a plus in between them, right? So now I need to multiply these factors together, and I'm going to do FOIL. And I like to multiply with the binomial first. So I'm going to multiply x squared times x squared, and I get x to the 4th. X squared times -6x is -6x to the 3rd. X squared times 8 is plus 8x squared. And now I'm going to go and multiply each of these 3 by 1. So 1 times x squared is 1x squared. And I'm going to line up my x squares. 1 times -6x is minus 6x, and 1 times 8 is plus 8. And when I combine my like terms, my polynomial is x to the 4th minus 6x to the 3rd plus 9x squared minus 6x and plus 8. And that is my polynomial that gives me these 4 roots. And lastly, number 7, I'm finding all complex roots. Now I'm looking here and I have a trinomial and I am missing my odd terms. So if I look at, what do I want to do? I don't want to do that, never mind. If I look at this, I can factor this and say I have x squared times x squared would give me x to the 4th. Now I'm thinking of numbers that multiply to be 24, subtract to be 5, and that would be 8 times 3. I know one of them has to be positive and one of them has to be negative, And because I have a negative as my middle term, the bigger number has to be negative. Now, you can always check this by doing FOIL, just going back in reverse. This is x to the fourth, plus 3x squared minus 8x squared is minus 5x squared, and then 8 times 3 is 24. Different signs make it negative. Okay, so this equals 0 if I'm finding the zeros. So here I'm going to set each of these factors equal to 0. X squared minus 8 equals 0. I'll add 8 to the other side, so x squared equals 8. And I'm going to square root both sides. So x equals, and I have a square root of 8, so this is just 2 square root of 2. And it's positive and negative. On this one, I have x squared equals negative 3, because I'm going to set this equal to 0, subtract 3, so x squared is negative 3. Square root both sides, and x equals plus and minus. Now I'm going to simplify this, and I get I square root of 3. So according to the function, it's a fourth degree polynomial. I should have 4 roots. Those roots are 2 square root of 2, negative 2 square root of 2, I square root of 3, and negative I square root of 3. All right, so that is it.